a word of prayer. Oh Lord, we thank you for this day. We thank you for the gift of life. We thank you for guiding us and protecting us during this physics lesson, Father. May you send the Holy Spirit upon us. May we be able to understand and cooperate with the teachers, and may we have good connection. In Jesus' name I've prayed. Amen.
Amen. Thank you so much, Christabel.
Colleagues, we had started doing calculations on density, but our lesson ended when we had not covered any numerical questions as far as relative density is concerned. So today, we wanted to go through that experience of carrying out some questions, numerical, especially calculations that will involve relative density. So, Mr. Chakoni, we had kind of like relied on you, whether you had some questions for us. But in case you don't have, I don't know what your response is. In case you don't have, we are getting a few here. We want to use those, and then the girls can also go through the space of finding or going through calculations involving relative density. Mr. Chakoni?
Mr. Senjobe, I'll be sharing some questions shortly. I'll be sharing some questions. I can start.
Yes. If you have anything to share with us, please share, and we start from there.
Okay.
Maybe as we look for the questions, can we have some review questions to the girl?
Okay. I'm going to ask Apio Grace. Is Apio Grace there?
Apio, put up your hand.
Apio Grace. Apio Grace, you are there?
Apio, put up your hand, and if you're there,
I'm going to be calling your names randomly. I'm calling on Apio Grace. That is the one where we shall know whether you are attentive or not. Is Apio Grace there?
Yes, she's on, Mr. Chakoni. I mean, Mr. Sanjay.
Apio is, can you remind us what relative density is, please, Apio Grace?
Density is mass per unit volume. Is a ratio of mass to volume.
Relative density is what?
She said the ratio of mass per unit volume. That's what I heard.
Ratio of mass per unit volume. Is that our definition? Can we get another definition from Ayebale Christabella? Is it Ayebale? There is Daniela. There is Daniela.
Girls, don't open your microphones.
Relative
please.
Density is the ratio of the density by the ratio of the substance.
Daniela, that is still missing.
Girls, don't open your microphone. Mr. Sanjobe, yes, Mr. Sanjobe, pick those who have put their hands up such that girls don't open their microphone.
I was looking at Mirembe Emily. Mirembe Emily, unmute.
Teacher, relative density is the ratio of the density of a substance to the density of water.
Very good. That is what if I define as relative density. Please write it down, those who have forgotten, because it is what we are going to be using. Okay, relative density is the ratio of the density of substance, the ratio of the density of a substance to the density of water. Okay, that is okay. Mr. Chakoni, I think we are good to start with the questions. Please share. Oh, do they see your screen? Yeah, because you have to start with a question. we'll start with that one. Kuanga, Mr. Chakon.
Okay, as we wait, girls, what is the
Mr.
best
Chakon,
time?
Is jumping. I don't know why. Okay.
Mr. Senyobe,
What is Sebo?
I don't know if I'm sharing that question or not, but this, are you able to see my screen?
Yes, I'm seeing your screen now.
Yes.
Now, this question involves the density bottle. I don't know that these learners are ready to get into that
Not yet.
problem.
The only challenge, Mr. Chakonye, is that we did not have a density bottle yet in our notes. In
Could
this
we use
one
this
note,
opportunity maybe to
go through the density bottle. Okay, let us first get this question. Then we go through the density bottle.
Okay.
Is that okay?
If it's going to be an issue, then we can get away from here and then look. Okay. First, I beg your pardon?
Yes, it is okay. It is okay, we can go through it, Mr. Chakonye, but let us first start with a simple question, and then we move on to that question. I think it will carry us. Okay.
Okay, so I share.
Girls, you unshare a bit, and then we shall start on that one. Girls, concentrate on Madam Javira's screen. I hope you can see that screen. There is a question that's going to be put on the board, and then you are going to see the screen very soon. Madam Javira's screen, can you see? Can you see Madam Javira's screen?
No.
No.
No. Tap on Maria Goretti.
No.
Mr. Bruno.
On her screen, I see a chalkboard.
Yes. That is the screen, Maria Goretti. If you have seen Maria Goretti, you tap on that screen, and then that's what we want you to see. Are you there now?
Yes.
Yes.
No.
I've seen it.
Teacher, it's refusing. What to have video and double tap it?
Maria Goretti, just tap there on that. Maria Goretti.
Teacher, for me, when I tap there, it instead moves Maria Goretti to another place.
You center your cursor and tap.
For mine has refused. Mine has refused.
Yours
like my
has
cursor is a finger, is a hand. Like when you tap something, it moves it from one place to another.
Okay, let me read the question for you. You write it. You write down the question.
Okay.
A substance has relative density of 2.3. A substance has relative density of 2.3. Full stop. What would be the mass of a volume? What would be the mass of a volume of 100 centimeters cubed? Of 100 centimeters cubed of the substance, in brackets, density of water is 1 gram per cubic centimeter. Density of water is 1 gram per cubic centimeter. Okay, I want us to pick one of you to try to find a way through that question, to navigate us through that question. Is anybody who has read that question ready to tell us what she would do?
Excuse me, teacher.
Yes, please.
I can't see the question and I had gone
I've
off.
read the question. I told you I'm going to read the question. You did not hear me even.
Mr. Sanjay, let's find out of sharing the screen because these girls get back because of the connectivity. That's
so can I read the question? Can I read the question again?
Yes, teacher.
A substance has a substance has relative density. Yes.
Can we try to have the question on board? Like, let's connect the question.
It is there. It is on the board, Mr. Sally. That's why I'm reading. I'm wondering why the girls don't see it.
Even
tap Madam Mary Javira and you will see the question. Mr. Sally, have you seen the question?
Yes, it has come. So they need to tap the window for Teacher Javi, then it comes on their screen.
Actually, I'm wondering, this is the first time they are saying they are not seeing it. For so many the lessons we have had, I don't know what has happened today.
It's too like we can't. It is so even when I try to tap the window, it only remains there. So like I can't see. Yeah, we need like something.
You double tap it. If you're using a PC, you have to tap on the 3 dots and click pin, then it will break.
Double tap, then pin.
Double tap on
Thank you.
Hey, so we are okay. Thank you, girls. I knew you were IT, so you tell whatever. So are we now? I don't need to read now. I hope everybody sees the question. You're using a. It is still what?
When someone is using a phone, they should just scroll to the other side from the main screen to their right side, then double tap the screen of the teacher.
Yeah, to where the windows are, then double tap. Yeah. Has worked.
Okay, we have seen the question. We have wasted a lot of time trying to see the board this time. So please, can somebody guide us through the solution?
Yes.
Yes, who is that one? Who is ready? Who is ready?
Teacher, I'm ready.
Who are you?
I'm our D4.
Our D4. Can you guide us? Tell us what to do.
Yes, teacher. So it says the relative density of the substance is 2.3. The volume of the substance is 100 centimeters cubic centimeters. So it says what is the volume? What is the mass of the substance? So to get the mass, it also says that the density of water is 1 gram per cubic centimeters.
Yes.
So to find the mass, you first find the density. So to find the density, you just multiply 2.3 by that density of water. You'll get 2.3 grams per cubic centimeters. That's the density of the substance. So now to find the mass, you put the density of the substance times the volume of the substance, which is 100 cubic centimeters. So it will be 2.3 grams per cubic centimeters times 100 cubic centimeters. And the answer will be 230 grams. And that is the mass of the substance.
What the answer?
The answer is 200.
Thank you so much. Thank you so much for what you said. First of all, you identified the density of the substance, where it is density, the relative density times the density of water. It comes from the fact that relative density is density of the substance divided by density of water. That is where it comes from. So the density of the substance would be relative density times the density of water. That is what we've done here to give us 2.3 grams per centimeter cubed. Then she went ahead and said for us to get mass, so we begin from what we know. We know that density is the same as mass divided by volume. Now, if we make the mass the subject, it means you cross multiply the side. You multiply volume times density. That is why I've put the arrow. It implies that mass is density times volume. Therefore, the mass of the substance will be the density, which we've got as 2.3, times the volume, which was given us 100, giving us 230 grams mass of the substance. Thank you so much, Brown. I've simply written what you've guided me to do. Can we pick some questions?
Nanyans Ozana, unmute and submit.
Follow what they are telling us. It was a simple question to remind us about relative density.
Nanyans.
Nanyans, are you there?
I understand you are working with the new arm is up. Can you tell us what your question is?
Nanyans Hosanna.
Okay, let's get to Mugabe Michelle. Mugabe Michelle, unmute and submit. Mugabe Michelle.
I wanted to ask, since relative density, yes, I wanted to ask, since relative density is a ratio, why is the question putting it as a decimal?
She said since relative density is a ratio, why does the question put it as a decimal? Something like that. I had also noted my things.
Hello?
I was saying, if relative density is described as the ratio of the density of a substance to the density of a liquid, then why is the question?
Don't density of a liquid, that last statement is wrong. It is density of substance to density of what?
Water.
Water. That density must be water. So it is very specific. So what are you saying?
If relative density is the way I've defined it as, then why is the question stating that the relative density is 2.3? Why is it in decimal form rather than in a ratio?
But relative density is a value. I think we talked about that. That value can be bigger than 1, can be bigger than whatever, but it's just a value. So relative density will be 2.3, which is equal to density of a substance divided by the density of the water. So we can use that formula to find the density of the, I think, okay, they are going to explain it to you.
And then I think, Mr. Sanjove,
Wanji?
according to our question, a ratio can also be a decimal. I think that is our concern. Why is it a decimal yet it's a ratio? Ratios are fractions. So a ratio can also be written in a decimal form. That's what I picked from our question.
Okay. But can we first put it that a ratio is a value? It can be any value.
It can be a decimal, it can be a whole number. Mugabe, are you now okay?
Yes, I am.
Okay, then Natikude Gladys, unmute and submit.
Teacher, can you please elaborate more on the question? Like, I'm kind of confused because is the substance that has the relative value the same as the one we are going to find for this question.
Okay, Gladys, can you look at the chalkboard? I've tried to put more details. We are beginning from relative density as the density of a substance divided by density of water. So I'm going to, when I make density of the subject, the subject, I mean density of the substance, the subject. This is what I'm looking for. So I've made it the subject and it's the same as cross multiplying here. Relative density times the density of water. That is why I have this statement here. That the density of a substance, you simply take its relative density times the density of water. We've been given the relative density as 2.3, and we're also given the density of water as 1 gram per centimeter cube. So when you multiply the two, we get the density of a substance as 2.3 grams per centimeter cubed. But they want us to find the mass. What would be the mass? Then when we go to our known formula, we know this formula in this format. That density of any substance is the mass of the substance divided by the volume of the substance. In this case, I'm interested in the mass, so I've made it the subject. Mass, if I begin with mass of the substance, it will be density times volume. That is what I have here. Mass of a substance is given by density times the volume of the substance. We have calculated here that its density is 2.3 grams per centimeter cubed, and we were given its volume as 100 centimeter cubed. So I've simply substituted here. Now when you multiply 2.3 times 100, you end up with 230 grams. Therefore, the mass of that substance is 230 grams.
That's good. Are you now okay?
Yes, teacher.
Okay, Ozana Nanyanzi, unmute and submit.
Yes, teacher, I have 2 questions. I have just come in and I don't, my first question is that I have just come in and I don't know what you are talking about.
And the second question?
I'm going through the number while you are there. You mean you didn't?
I got somehow confused. Then my second question is that I lost connection and I didn't get to finish the solution for number 1.
That's what we are still on.
That is what we've just done. That is what I've just gone through, number 1. I was re-explaining number 1, and unless you didn't pay attention.
Yes, and I lost connection. I didn't finish writing the solution.
Okay, let us explain. Relative density is the ratio of density of the substance to density of the water. Do you see that formula RDS is equal to DS over dW?
Yes.
Okay, so we are looking for the density of the substance, so we have cross multiplied relative density times density of water. Is that okay with you?
Yes.
So we have got the density of the substance as what? Oh, you are not writing. Have you got the density?
I was first waiting for you to explain, then I.
So, okay, I've written the density of the substance. You are going to hold us behind, madam. We are 15 minutes into the lesson. So have you got the density of the substance now?
Yes.
Okay. Now, remember the question is interested in finding the mass. So we go to the definition of density in terms of mass and velocity and volume. So we make the mass the subject of that formula. Is that okay? That is the second part of the board. Then we know the density, we know the volume, we get our product as 230 grams. And that we have answered the question. Are you okay now?
Yes. Yes, please, teacher. Thank you.
Mr. Chakonyi, I think we cannot tolerate any more questions. All those will be answered in the chat. Mr. Sali will handle. Can we move to the... Mr. Chakonyi, please share the screen. Mr. Chakonyi?
I'm going to do that shortly in the next 1 minute.
Yes,
let me do the needful.
So girls, Mr. Chakonye, you tap that screen for Mr. Chakonye. I hope now everybody knows how to get that. And share it ours.
So while we wait for Mr.
Okay, Mr. Senjobe.
Yes, sir.
Mr. Senjobe.
Yes, sir.
I think as we get to this question,
yes,
we can give the learner some brief to know that we can determine that, okay, based on that very formula of relative density, that it is a ratio of the density of a substance, the density of a liquid.
Yes.
The basis the background to this density bottle question is that the volume of a substance, the volume of that bottle is going to be the same. So we fill the bottle with a particular liquid, then with another liquid, and because the volumes are the same, then that brings us to gives us another formula for relative density, that it is a ratio of the mass of a substance to the mass of an equal volume of water. I think that background needs to be put across first, then we move to the question. Do you think so also?
I think so. Madam Pretty put. So girls, let us build that history.
Mr. Sanjay, did we handle density of mixtures, or it's something to do, because as soon as asking about it from the chat?
We did that last week.
I think it was done.
Last
week that question was handled.
She's asking about more calculations about it.
Okay, we shall see. Let's first finish this one.
Okay.
But otherwise, at least we had an example last week.
Okay.
Okay, now yes, Mr. Senjobe, I'm sharing something now. I believe so. Mr. Senjobe, are you able to see my screen? Are you able to see my screen?
Yes, we can read.
Okay.
Yes.
Okay. Let's start with a simple one.
Okay.
We can start with a simple one. I have had to modify the question to start with a simple one like this number one here.
Yes, please.
I hope students can read. Maybe we could get a student to read that question for us to be sure that they are really seeing the same thing.
Okay.
I can see Nachigude Gladys' hand up.
Nachigude Gladys.
Okay. Mr. Mugisha is a milk vendor. He collects milk from different farmers.
Number one, read number one.
Number one.
A density bottle.
A density bottle has a mass of 16 grams when empty, 46 grams when full of water, and 41 when full of a liquid. Determine the relative density of the liquid. That's question one. Density of the liquid is in SI units, given that the density of water is 100 kilogram meters cube. Yeah, that's a question.
It's 100.
It's 1,000. Okay.
Okay.
So we can capture the information. Yes, Sebo?
Yes. Yes, you are right. Let's capture let them capture the information. Then I think we might have to use that board for illustration.
Okay. So, girls, remove everything. Madam, remove everything. It's been no one is. Now, girls, let us capture the information as it is in the question. They have given us a density bottle has a mass of 16 grams when empty. So, Madam Javi is writing for the mass of the empty bottle when empty. So it is 16 grams, it has been captured. I hope you see her screen. I'm going to read for you the question. Just tap Madam Marie Goretti's screen and you see what is writing on the board. Then we have 46 grams when full of water. So the mass of the density bottle plus the mass when it is full of water is 41 grams. No, 46 grams. And 41 grams when full of a liquid. So the mass of the density bottle plus the mass of the liquid is 41 grams. I hope that information has been captured. So I'm going to ask, what is the mass of the water alone? Can anybody tell us the mass of the water alone? What is the mass of the water alone? I see Narule Rukia. Unmute and ask.
Tell the mass of water, you get mass of both minus the mass of empty bottle.
So it is 46 minus
16.
And we get that. We get 30 grams, okay? Now what is the mass of the liquid? Somebody else, I'm going to Namagembe. Namagembe, unmute and tell us the mass of the liquid. Yes, please.
May you please repeat? I'm kind of lost. The whole thing.
Okay, Kat, listen.
Teacher, the mass of the liquid.
Yes.
Teacher.
Yes, I'm listening.
Teacher, to get the mass of the liquid alone, we get the mass of the empty bottle minus, the mass of the liquid full of water, full of the liquid, then minus the density of the bottle when it's empty. So we get 41 minus 16, where we get 25.
Okay, good. But it is mass subtract mass. It is not mass subtract density. Okay, we subtract the quantities that are of the same nature. So that is 25 grams. Okay, now I'm going to ask you another question. What can you say about the volume of the water and the volume of the liquid? Can you say anything about the volume of the water and the volume of that liquid that are contained in the same bottle? What can you say about their volumes? You don't have to open books. We have the same bottle.
The volume is the same.
The volume is the same. Capture that, please. So the volume of the liquid and the volume of the water are the same because they are from the same container. That is very, very important when you are using what we refer to as any bottle or a density bottle. For us to get the proper relative density, the volumes must be the same. That's why we use the same bottle. Okay, now we are going to calculate relative densities using another formula, and this formula is, Madam, just a second part. So the relative density of the liquid in this case will be mass of liquid divide by, somebody seems to know, divide by what?
Mass of equal volume.
Mass of equal volume of water. Mass of equal, I took things for granted. Mass of water of equal volume. Mass of equal volume of water, that's quite important, Madam Jeff, we capture that. Mass of equal volume of water. Mass of equal volume of water. So please, she has written below because that's the part of that board that you can capture. So that is how we find relative density using masses. Now, can you tell us the values to substitute? I'm asking Nachigude Gladys has her arm up. I hope she's contributing. She's not going to tell us she doesn't know what we are doing.
Excuse me, teacher.
Can you substitute? Yes?
May you please repeat the explanation? Kind of confused.
We have said that the bottle, the volume of the liquid and the volume of the water are the same because they were from the same bottle. Did you hear that?
Yes.
So we have got the mass of the liquid and we have got the mass of the water by subtracting away from each the mass of the empty bottle. Is that okay?
Yes.
So we are now calculating the relative density of the liquid using a formula of, who gave us that formula? Somebody gave us that formula.
Me.
It was Rukia, I think. Can you give it to us again?
Mass of liquid divided by mass of equal volume of water.
So that formula can be used to find the relative density of the liquid. Is that okay now?
Yes, thank you, teacher.
So can we now substitute? What is the mass of the liquid we are using?
25 grams.
25 is giving us that answer. I want to know everybody who's participating, please. Give us your name and you give us your answer. Who was that who gave us 25?
Teacher, it was Mirembe Emily.
Mirembe Emily. So what about the mass of the water?
30 grams.
30 grams. Okay. Now, can you give us that value? It is the same as, we can simplify it to 5/6. So 5/6, what is the value that we get? 0.833. 833. And do we have a unit?
No.
Do we have a unit?
No.
Why don't we have a unit?
Relative density does not carry units.
The unit C, yeah, relative density doesn't carry unit C. Because the units, we are using the same physical quantities. So I think you have seen the units being cancelled. So relative density does not have units. So that idea which you have just put up is what is used to get the relative density of substances using a specific bottle. Here we talked about a bottle, but the type of bottle that is used in our experiments is called the density bottle. And remember, the rule for the density bottle is because the density bottle gives us the same volume of the liquid as that of the water. What you see below there is very crucial for the density bottle. Is that okay? We use the same density bottle because the volume of the liquid will be equal to the volume of the water. Okay? The volume of the density bottle, the volume of the liquid will be equal to the volume of the water. Sorry, it will be constant volume.
Mr. Sanjabi.
Yes, please.
I think we need to keep reminding that girls to tap, because in the chat there are students saying they can't see the screen. To tap, their friends try to explain. Those on the phone, you just slide to the right and then tap on the window that has the teacher's name. Then those on the laptop, just get to the screen and see that small window and click on it. You'll be able to see that screen.
And the name you are looking for is Marie Javi. Marie Goretti, sorry.
And then also, Mr. Sanjeev, I just wanted to add something small.
Yes, please.
Yes, learners also about volume of the liquid equal to the volume of water. You remember in S1, we learned about, we covered, Mr. Sanjeev, have we done states of matter?
These are S1s, Mr. Sali.
Yes, S1s,
So
Mr. Sanjeev.
One, yes.
We haven't covered states of matter, right?
No.
Okay, so okay, we shall learn there that.
Yes.
Yes.
Oh, I thought we find relative density
There is
using
a question.
densities. I thought we find relative density using densities, not mass.
Okay, let me respond, Mr. Sanjeev.
Who is talking? Is it Chiramo?
Yes, sir.
Yes, Chiramo, put down your arm now that you are talking. What are you saying?
Mr. Sanjeev, I got a question. May I try to respond?
Yes.
Yes, Chiramo, your question is, you thought we find relative density using densities, but then there's also another definition. We had that of the density, it is the ratio of the density of a substance to the density of water. But there's also another definition that says relative density is the ratio of a given volume of the mass of a given volume of a substance to the mass of an equal volume of water. So there's also that other definition, and it's now what it's where we are getting this formula. Let me repeat it. Relative density is the ratio of the mass of a given volume of a substance to the mass of an equal volume of water. So also when you look at that definition, we can also use it to work out relative density. And that's why in this case, we are getting these volumes using a density bottle because they have to be equal. Hope it's now clear.
Excuse me, teacher.
Mr. Sanjeev.
Yes,
I want us also to advise these girls to develop that habit of jotting down something. Whenever something is presented on board, let them have a pen and paper somewhere so that they keep writing or noting down something as the lesson progresses. Because we keep going back and forth. A student tells you, but why are you getting this formula from? Yet the illustration has just been put on board there. So let them get a pen and paper whenever they are coming for these lessons, write down something, because some of the questions would be answered by themselves by simply looking at what they have just written. Thank you. But thank you so much, Madam Javira, Mr. Sari, Mr. Sanjeev. I think you are doing a good job there. I hope our learner there is okay. Can I get to the next question?
Excuse me.
Mr.
Chakoni.
Okay.
Don't rush me, Linda. Let's take this down slowly.
No, I'm not. I think there is also part B.
Okay, guys. Well, by the way, girls, for us, we don't have recorded lessons. Forget about the recorded lessons. We don't have that time. Remember this season. I'm being very sincere. Don't ask us for things we have written down. We are taking a lot of time, so be serious in these lessons. Write down those notes. Send me anything where are the recorded notes. Okay? You work in class, so you should be here. Okay? So take things seriously, people. I hope we are done with writing that question and we can move on.
We have questions.
Yes, we are ready to answer the questions.
You're sitting on the bed. You can't sit on the bed while we are Kyla, Lala, Kyla.
Mr. Sari, please, somebody can me whatever. Can we move on? Divine Grace, what is your question?
I have my own name.
Excuse me, teacher.
Divine.
Okay.
Can we round off in this case?
Can we what?
round off.
Yes, you can round off to decimal places, but it's better. We told you start getting used to 3 decimal places. So there's no need for you to round off beyond that. Start getting used to 3 decimal places because we are even going to carry you to 4 decimal places. Okay? So rounding off 3 decimal places, get used to that. Next, another question is Mugabe Michelle.
I wanted to ask, can we write our answer in ratio form?
As 5/6, it is okay, but it is okay. It will depend on what the need is, but it is okay. I have no problem with that. And you are right, you are saying fraction 5/6, it is okay. As long as you don't put the unit. But please get used to those.
Mr. Senjobe.
Why Sebo?
Mr. Senjobe?
Yes, Sebo.
Yeah, let us encourage them to get used to decimal points and desist from giving fractional answers in physics. We don't very much like fractional answers in physics.
Okay. In math, it is okay. Physics, no. Okay. Anybody? We don't have questions, Mr. Sali. I don't see all arms are down. So I think we can go to the next. There is Nyende Louise.
Teacher, I'm asking, what is a density bottle?
Hey. Do you have any bottle at home?
Yes.
Which is free, like a water bottle. What if you want? If you want, you can use that mineral water bottle as a density bottle.
Okay.
But a bottle, it is just a bottle. That's what I don't. It is not really that specific. I hope you get the idea. It is just a bottle, but what we use it for is that we make sure that the same volume of liquid we are poured in is the same volume of water that we pour in. So any bottle can serve as a density bottle.
Okay, thank you, teacher.
Though in the labs we try to specialize them. Is that okay?
Yes, teacher.
In the lab we specialize them, but any bottle can be used as a density bottle. As long as it is small enough and portable, you don't get your father's wine bottle, which is 3 kilograms, and then you use it as a density bottle. That will be too cumbersome. Okay? A small bottle will work for you. Nyanzi Hosana? Na Nyanzi. Nanyazi?
Yes, teacher. Yes, teacher, I have a question.
Yes, that's why we are trying to get it over.
Here on the solution, I'm seeing M, then I'm seeing like a capital DB. What does this DB mean?
Okay, DB stands for density bottle. The one is the water. We have added water in the density bottle. And then we have added the liquid in the density bottle to get those different masses. Now we are interested in the mass of the water alone. It will be mass of the water plus density bottle, subtract away. Is that okay?
Yes, teacher. Thank you.
Okay. Nachigude Gladys.
Teacher, my question is that there where I said the other part of relative densities, mass of any volume of water out of mass of water. Does equal volume of water also mean mass of volume? Okay, like what does equal volume of water mean? Can't you just say mass of water?
Nachigude Gladys. In any statement, English statement, there is what we call the subject. What is the subject of that statement? Mass of a given volume of water. What are you really concentrating on? Are you concentrating on the volume or the mass? Which is the subject?
On the mass.
It is the mass. Altogether, it is like telling me Nachigude is so and so's daughter. But the person is what we are talking about is Nachigude, not the whatever. Altogether, so the mass of this substance must have the same volume as the water it is being compared to. That is what they must have in common. The mass of the substance and the water we are comparing it to, they must have the same volume in common. That's why we have that statement written down there that volume of liquid is equal to volume of water. Is that clear?
Okay.
Yeah, that's the only feature that they have. Okay? I hope I've answered Nachikude's question and everybody. Nanyanzi, I think we did. Nanyanzi, I think put up down your arm. You have really asked too many questions. Kahunguka Charity. Kahuga Charity?
Excuse me, teacher. Excuse me, teacher. I had gone off when you
And you're also going off
were
now.
still explaining the other first right now. I was asking if there is a way of telling me what you have been talking about.
Okay. What I've said is that the mass of the substance and the mass of the water, to which it is being compared to, must have the same volume. Both of them must be of the same volume or of equal volume. That's all that I said. Is that okay? There is nothing good at Gladys. I'm wondering why she's putting.
Should I even not
Mr.
get these calculations that
Sanjove.
are on the screen? Because I don't know when we were discussing the very, very first question, and I have just joined.
Mr. Sanjove. Let's try to re-emphasize the issue of using a density bottle. It's what gives us equal volumes, because there's a question in the chat. If you are talking of equal volumes, then why are we dividing 25 by 30? So such a student, I think, needs to know that from the definition, we come up with that formula, and we're actually dividing with masses, not volumes. It is from the chart.
Can I try to illustrate something also on the whiteboard here briefly?
We have 1 minute.
Thank you.
Mr. Chaponye, please use the minute.
Okay, thank you, Mr. Senjove and Madam Javira there. So I think what we are saying, girls, is that a denser bottle, like Mr. Senjove said, is really any bottle, as a matter of fact. Okay? Is any bottle. So if you look at that as a bottle, for example, if you're looking at that as a bottle, usually it has some cover. It has some cover, and when you cover this bottle, when you fill it with a liquid, get its mass, then you fill it again with another liquid whose density you want to find. After that, get to the formula that relative density is equal to the density of that substance divided by the density of water. Now, what is the density again? Let's go back to the definition of density. Density is mass of a substance divided by volume. I don't know whether I'm lost there.
No, you are okay. Put the mass over.
I was writing something. Okay. All right. So I think what Mr. Senjo is saying, what our learners should really get to know is that, unfortunately, I seem to have lost.
Can Mr. Kizito come and control your computer again?
I can't. Okay, Mr. Senjobe. What I wanted to suggest here is that can you try to derive the formula for density, write the formula for density of a substance in terms of mass over volume, then down there in terms of mass over volume, and then they see the volume is cancelling so that they can see where the formula comes from. And then we move ahead. Because that's what I wanted really to show there.
Remove the something we are trying to get.
Yes, Madam Javi has put it up there. Yes. Exactly. Exactly. That's very good, Madam Javi.
So
yeah, very well.
Okay, we are picking it from the formula that we all know. that relative density is density of a substance divided by the density of water. So I'm using S is standing for substance, then W is standing for water. So instead of density, I'm putting, since we already know that density is mass over volume, that is for the substance, then down here, I also have for water, it is mass of water divided by volume of water. Now, but since we use the same density bottle, whose volume is the same, that is why I said but volume of water is equal to the volume.
Javila, we've lost your sound.
Unmute.
Your sound is lost. Your volume.
Okay, sorry. So when let me go back. Relative density is density of a substance divided by density of water. That is what we all know. But we also know that formula for density is mass of the, now S is standing for substance and W is standing for water. So for the density of the substance, it will be mass of the substance divided by volume of the substance. Then down here, density of water will be mass of water divided by the volume of water. But remember, in this case, we use the same density bottle. It means that the volume of the substance is equal to the volume of water because the container we used was the same. So I'm going to rearrange this. This is the same as mass of substance divided by volume. Now let me do this. Volume of substance is equal to volume of water is simply equal to V. Now I'm baptizing it just V because they are the same. So getting here, I have there for now mass of the substance divided by the volume. I mean, yes, then divide by, I'm trying to rewrite this. It is this divided by mass of water divided by the volume. We've agreed the volume is the same. So if I rearrange this, I'll have mass of substance divided by V times the reciprocal. This one we know very well. Volume divided by mass of water. So in this case, since the volumes are the same, they cancel out. And therefore, I end up with the final answer. Or our new formula today, that relative density is the same as mass of the substance divided by mass of water. But we need to be strict that it should be the mass, the volumes must be the same for you to use this formula. Mr. Chakon, is that okay now?
Yes, Madam Javi, I'm very comfortable. Thank you very much. I think that should be okay with our learners as well. It's well put there. Thank you.
Excuse me, teacher. Excuse me, teacher.
Yes.
If the volumes are not the same, then what do you do?
You cannot use that formula.
What formula do you use?
That's why we use the same bottle to make
If
sure
if the volumes are not the same, then you cannot use this formula.
So what formula do you use?
The other one for density, you have to find their respective densities.
Okay, yes, thank you.
Welcome.
Mr. Excuse me. Mr.
Colleagues.
Yes, Mr. Chakon.
I wanted to suggest that since we've run out of time, maybe I put this question, I share these questions and the learners copy them and then they try them later because we already past time, I think.
Yes,
Don't you think they might have to try?
Maybe we shall.
But this is what's
Okay, Mr. Chakon, I think you're right. You will share those questions on Google Classroom and probably the WhatsApp groups so that they can look through and try to relate what they've learned today and the example number 1. Then they try to go through the other examples. Then so that next lesson we simply compare our answers and then we move on. I think we shall finish density in the next lesson this week. We shall wrap it up.
Excuse me, teacher.
Are you